In this lesson, we're going to get a quick overview of virtual private networks or virtual private networking. Now realize that the most common way to get protection in a VPN is to use some cryptographic technology, a crypto system, for example, AES. However, you don't have to use cryptography to virtualize your private network. You can use encapsulation, compartmentalization, and other techniques like dedicated leased lines. However, today we use VPN gateways installed on head-end devices at headquarters and branch offices, regional offices, physical and virtual appliances at cloud providers, and other points of presence on the network. A VPN gateway is a dedicated termination point or a concentrator for various types of VPNs. The two main types of VPNs are site-to-site VPNs, where you have a device at two different sites, creating a tunnel between them, and remote access VPNs, where users using endpoints like laptops, mobile phones, and pads, with or without some type of client software, will connect remotely to the VPN gateway. You can even have a VPN connection between two endpoints or two laptops over the internet. VPNs can support IPsec or IP security, Internet Key Exchange version 1 or Internet Key Exchange version 2, the newer version. They can also support SSL/TLS protocol suites. Now, when we say SSL/TLS or Web VPN, we're almost always talking about transport layer security version 1.1, 1.2, 1.3, or higher moving forward. But most commercial VPN solutions today are going to be using IPsec for IP version 4 or IP version 6 and or transport layer security. And a VPN can be a server or appliance-based solution. It can be a physical appliance, often with a high availability solution, maybe a cluster of those devices, or a active standby scenario, or they can be virtual. Let's say an adaptive security appliance V from Cisco installed in a hypervisor or running at your cloud provider. Routers and firewalls have been common VPN gateways, although there are dedicated VPN gateway solutions. In the diagram, we have our headquarters, and at the headquarters, we have some type of customer premises equipment that is serving as the VPN gateway or the VPN concentrator. We call it a concentrator because it often concentrates multiple types of connections. For example, it could have several site-to-site VPNs to different locations, like remote offices, branch offices, small offices, regional branch offices, but it could also have remote access VPNs to teleworkers at home or mobile workers and traveling workers. So it concentrates several different types of VPNs using different security suites and security policies, different combinations of protocols and services to get confidentiality, origin authentication, and integrity. They may even connect to a cloud service provider. The cloud provider may be just another spoke in their hub and spoke cloud, or it could be providing a managed site-to-site VPN back to the headquarters or one of the remote offices. Remote access VPNs, for example, the mobile worker in this diagram, can be a client-based solution or clientless. If it's a client-based solution, the mobile worker will install some type of VPN software, for example, OpenVPN or Cisco AnyConnect Mobility Client. If they do, they're going to get full functionality when they connect to the headquarters, or perhaps they're connecting to the cloud service provider using what's called a peer-to-site VPN, or in AWS terminology, a client endpoint. If it's clientless, they're just going to use a supported browser that the VPN gateway recognizes, and they'll just put in the URL or the IP address to the VPN gateway, and it'll push down through XML some type of portal, and they can get limited web-based access to some resources. IP security or IPsec has two main protocols historically. IKE version 1, which is an older protocol that uses two phases, initially creating a peering connection. We call it IKE peering, between the two devices, maybe at the headquarters and the remote office, and then a tunnel between them. Ike version 2 is newer, it's faster. It actually uses elliptic curve cryptography so that it can actually be better for mobile devices. It gives you better security with a smaller key space, and it supports newer security suites for compliance with, let's say, federal agencies and things like that. So Ike version 2 is preferable, and it doesn't have two separate phases like Ike version 1. It's much faster and more robust and more secure. IPsec can run in tunnel mode, where you're setting up a tunnel between two devices, or if it's a cloud provider site-to-site VPN, there's a tunnel, or usually two tunnels for high availability, two logical tunnels to a virtual private gateway at the cloud provider and your customer device at your headquarters or your branch office. With tunnel mode, there'll be an additional header on the outside that will have the IP address of the device, the public IP address of the device at your headquarters, and a public IP address of something of the gateway at the cloud provider, an address that they'll provide. Transport mode actually maintains the original address and the original header. So you could use transport mode, for example, to set up a VPN gateway using OpenVPN between two laptops over the internet. The two main protocols of IPsec are authentication header and encapsulating security payload, ESP and AH. ESP gives you all the services. It gives you confidentiality, it gives you origin authentication, and it gives you integrity mechanisms using a SHA-1 or SHA-2 HMAC and some type of AES for confidentiality. Authentication header is much thinner. You don't get privacy or confidentiality. It doesn't encrypt the actual payload. So you wouldn't use authentication header over the internet, over an untrusted network, but you could use it internally, like in your headquarters between a front-end SharePoint server, for example, and the back-end SQL server. We use ESP almost exclusively over the internet, although there are some exceptions with some VPN technology. Let's say you have a user that is a mobile worker and they have a workstation with a VPN client installed and they're working from home. Maybe they used to work in the office, but something came up and now they're a teleworker. You can set up that VPN client to either do split tunnel or full tunnel. If it's full tunnel, everything that the mobile worker does on their workstation goes back through the VPN gateway at the headquarters so that you can do URL filtering, content security, data loss prevention, all those really good things. Split tunnel says, well, if the mobile worker wants to go and surf the web and just do, web surfing, then it can split off, go through its service provider and go surf the web. If they need to access resources at the headquarters, then they'll go through the VPN connection. Often, however, you're going to set up that mobile worker to have always on VPN so that whenever they turn on that laptop or that workstation, the VPN back to the headquarters is on and you don't allow split tunneling. You want everything to go through the headquarters for, like I said, URL filtering, data loss prevention, acceptable use policy, all those great things. And again, IPsec can work with IP version 4 and it can work with IP version 6. As a matter of fact, IPsec is native now to IPv6. IPv6 has two extension headers included, an AH extension header and an ESP extension header to make it native to IP version 6. But don't forget, you can also run SSL TLS over IP version 4 or IP version 6. And your VPN could be based on a site-to-site managed VPN from your cloud service provider. And all of the big three provide a managed site-to-site VPN solution. You'll either do static routing or you'll use the border gateway protocol. BGP is the only dynamic routing protocol that you can use with your cloud-based site-to-site VPN solution at AWS, Google Cloud Platform, or Microsoft Azure.